So graphing part 2. So we're going to focus on two special situations. One where it's just like y equals a number or x equals a number. How do you graph those? And then we'll also look at situations where it's not in y equals mx plus b form. We'll see how to graph those as well. If there's time, this is a part that I would like to get to, but if we don't, it's not a big deal. It's graphing linear inequalities. So instead of equals, like how do you graph it if it says less than or greater than? Okay, so we'll do that if we have time. I don't know. We'll see how time allows. All right. So let's begin here. So find this slide on your notes and write along with me here. Now, if you ever have y equals a number, it's going to be a vertical. Sorry, take that back. It's going to be a horizontal line. And if you ever have x equals a number, it's going to be a vertical line. So let's do our first example here. So our directions are to graph. Let's graph that one. All right, so this says y equals 6, right? So this is the y-axis, this is the x-axis. So we're going to find where y equals 6, which is going to be on the y-axis. So we're going to go up 6. So that's where y equals 6. And we said that when you have y equals a number, it's just going to be a horizontal line. So it's going to look like this. Now the reason for that is because this equation has no x in it. So it doesn't matter what x value you pick, it's always going to, the y value is always 6. So for instance, if I were to pick this x value here, x equals 1, well on my graph, the y value is 6. Or if I were to pick this x value way out here, let's say that's 10, the y value that goes with that is still 6. It's always 6. So that's why it's a flat line like that. A second example then. X equals -3. Now you'll notice this one's different. This is x equals, right? You'll notice that since it says x equals, we're going to go on the x-axis this time. That's my x-axis, that's my y-axis. So I want to find where x equals -3. Is that top right, bottom, or left? Left. It's the left. So there's that, and we said x equals going to be a vertical line. Okay. So they look like that. And similar explanation here. There's only an x in this equation. Okay. Every point I pick on this line, the x value is always going to be -3. The y value could be different. It goes up and down, but the x is always -3. So that's why it looks vertical. So y equals and x equals 1. So that's our first topic for graphing today. So you guys one of these to do. SP stands for student practice. So would you guys graph these for me, please? there's 6 is that y-axis. And then we said we have y equals a number, it's going to be 4. And you have x equals 3. So here you're going to find your y equals 2. No, you don't have to put the extra points. Good time to check your answers for the name. I'm going to call you up here and share your work with us in a sec. Compare your answers with your person on your left or right there. All right. Ready? So, Leah, would you do number 1 here for me? And then Denise, would you do number 2 right here for me? And then last person. Maya, would you do number 3 over there for me on that board? Would you do number 1 for me, Leah? All right. And you can just write with your, or there's a pen here too if you rather use a pen. But you could use your finger or a pen, it doesn't matter. It's okay. I can erase it for you. You want me to erase it? I'll wait till you're done. Thank you. All right. So y equals -2. So if this is your x-axis here, you would go down 2 spaces and put a horizontal line. This line, I'm not sure. Maybe you were going for one of the other problems, but we don't need that one for number 1. Just this guy down here, 2 spaces below the x-axis. On number 2, vertical, 4 spaces to the right. And number 3, y equals 0. That's just the x-axis. So any questions about those ones? Nada? All right. So that's our first objective for the day, is just graphing those kind of weird ones. Now let's take a look at another odd circumstance. Whenever they're not in y equals mx plus b form, what we need to do is we need to put them in y equals mx plus b form. And we do that by solving for y. Okay? Do that by solving for y. So if you have a linear function that's not in y equals mx plus b form, we're going to change it to that form by getting the y by itself. All right? So let's take a look at an example there. And if you guys ever need me to slow down or something, just let me know. Yeah, something like that. Sure. Fill this out one little bit. Okay, so let's see what to do here. So I want to get y by itself, all right? By getting y by itself, I mean I want this thing to look like this, y equals stuff over here. So I don't want anything that's over here with the y to be there. I want to get rid of it all. So I want to get rid of the 8x, and I want to get rid of the negative 3. Okay? So let's do that. Now we talked about solving a little while back. Addition and subtraction comes before the multiplication and division if you're going to be trying to get a variable by itself. Okay, so let's. I wonder if I should ask. Does anybody know what you would want to do first here?
You would subtract 8 from both sides.
Good. You're going to subtract 8 and x at one time. So that's like one object. So since that's a positive 8, we're going to subtract it to get rid of it. You do the opposite, right? Since it's a positive, we do a negative, right? Just like that. So that's gone. And we have a negative 8x and a positive 6. Notice I didn't add these together, right? I didn't do negative 8 plus 6. Why not?
Because they're not like terms.
They're not like terms. You can't combine them. And what's this negative 3 doing to the y? It's multiplying it. So what's the opposite of that? So we're going to divide the negative 3, right? And when you do the division, you're going to divide all of them. Divide all 3 of them. Now, just so you guys, I'm going to change this, but I'm going to put this back. I just want to show you. You could technically write this. This would be true. But I want it in this form. So I want to make sure I write them separately. So I'm going to do this. I'm going to divide each one separately by the negative 3. That way we have the two pieces separated. Right? So negative 3 divided by negative 3 is 1. And that would be 1y, and we don't need to write the 1. Negative 8 over negative 3. Those don't divide or reduce, but the negatives can cancel each other out. So that would be 8/3. 6 does divide by negative 3 to make negative 2. And now it's in the graphable format. Okay. All right. So, Aaliyah, for this equation here, what's my y-intercept? Aaliyah.
Oh,
What's negative 2? Good. And so I'm going to put that on my y-axis. This is all from yesterday at this point, okay? Shimani, what's my slope of this on this equation here? So that's the y-intercept. So the slope would be 8/3. Okay. Michael, the 8 tells me how far to go Which way? Good. And Crystal, the 3 tells me how far to go. Right. So I'm going to go up 8 over 3. And when I do that, Natalie's here today. Jeremiah, when I do that, where do I start from? I'm going to go up 8 and over 3. Where do I start from to do that? I'll give you a multiple choice. Either the origin or the point that I just graphed. Yeah, wrong. I'm sorry. It's the point you just graphed. So from here, we're going to go up 8 over 3. So 1, 2, 3, 4, 5, 6, 7, 8, and then over 3. And there's your graph. So that was from yesterday at that point. But all of this was the new stuff for today. Just getting that y by itself. Okay. Let's do another example here. All right, let's say I have 5y minus 8x equals 15. All right, why don't you take a minute, see if you can think about what would be the first move here. What would be the first move to make? You can check your work with one of your partners there if you want. I'll call on you in a second. I'll ask you, what's the first move to make here? What do you think, Adriana? Good. So why are we adding the 8x this time? Yeah, so you want to do the opposite. Since it's minus 8x, we want to add it this time. So we have 5y. Remember, our goal is to get the y by itself, so I'm getting rid of the 8x right now. Okay? Try and see if you can do the second move there. Yeah, sure. What do you think, Adrian? Sure. Troy. What do you think, Edwin? Correct. So the 5 is multiplying the y. So you really divide. So 5 divided by 5 is 1. This is 8/5. And this is 3. Go ahead and graph your line. I'll give you a second for that. Go ahead and graph that line. All right, so it should look like this. You start at 3, you rise 8, and run 5. Looks something like that. All right, so let's see if you guys can handle one on your own here. I'm going to do student practice here. Let's say I gave you guys negative 4x. Do minus 3y equals 6. There you go, do it that way. Slope-intercept form, the y equals negative b in the graph. No, yeah, it doesn't divide like perfectly, and then it just leaves it around. That makes sense. So like here we have 6 over 3. 3 goes into 6. That's twice. But 3 makes it see it around. Because that's going to be a negative 2 because 6 away. Oh, other than that. Get done, check your work with a neighbor. We're going to go over it shortly. Is it down? Yeah. This one actually. This one. Everything else is good. This one's good. 4 over 3. All right, so I'll call someone up here. We're going to have one person do the math, like where you put it in the right form, and then another person graph it for me, okay? So let's have Alondra, what did you get for the equation? Did you get to finish yet? Okay. Brianna, what did you get for your equation? Cool. Would you do it on this little whiteboard for me, please? Show people how you got that. And then Kimora, did you get negative 4 over 3 minus 2? Did you get the graph?
No, I'm figuring out.
Okay. Do you want to do it on the board, or do you want to wait?
Yeah.
Wait. Okay. Would someone else? Does someone who got that negative 4? Okay. Go ahead, Denise. Thank you.
What was it again? -4. My bad. Go ahead.
Thank you. All right, so for the math for the getting it in the slope intercept form, notice that she added 4x first on both sides, and then after that she divided by -3. So you divide the y here, you get just the y's left. And then if you do 4 over -3, just write it as a fraction, 4 over -3. Now someone had, when I was out working, somebody wasn't sure, like, how do you know when to reduce it or leave it as a fraction? Well, if you can reduce it, then do so. But 4 over 3, that doesn't reduce. 4 doesn't divide by 3 evenly, so just leave it as a fraction. But notice that 6 does divide by 3 nicely, so we can just make that -2. And so there's your equation. So we start at -2 on our graph. And then now the way that this is written, you could go, I'm writing on the side of my whiteboard, you could go up 4 and left 3. That would be fine. And I think that's what Denise did, up 4, left 3. But maybe you put the negative on the top after you simplified, and maybe you just went down 4, right 3. It doesn't matter. You would have just had this point over here instead, and your graph would look something like that. Okay? So that's our second objective for the day. So we talked about graphing 2 special circumstances. Circumstance number 1 is where there's just y equals a number or x equals a number. Those are horizontal and vertical lines. Then we have these things where it's not in the slope-intercept form. So what do you have to do? You've got to get y by itself so that it is, and then you can graph it, okay? So that being said, let's go ahead and see if we can plow into our next topic here. No, it's the same one. It's just that I put this till last, so if we didn't get to it, it's not a big deal, but we'll try to cover it a little bit. Okay, so you don't need to write this. I just want you guys to watch for now and pay attention. So when you have an equation of a line, like let's say I have y equals x plus 1, right? Longer? Want to do this? Pay attention. Because I know you didn't get the last one, but you didn't watch the explanation for that either. You gotta pay attention and get it. All right. So my y-intercept is 1, and notice there's no slope there, so that means that it's 1. So it's 1 over 1. So I'm gonna rise 1, run 1. Started from my y-intercept, I rise 1, run 1. And then I'm going to connect my dots. Now, once again, you're not writing this, you're just watching. No need to write. Okay. Now, I want you guys to understand what an equation is. It's basically, it represents the infinite number of points on this graph. So, Stephen, pick a number for x for me, any number. 4. So Steve's going to pick 4 for us. So if I plug 4 in for x, what's y going to be? 5. So that means when x is 4, y is 5. Now my graph's not perfect, but it would be about that point right there. Okay? So basically, what this equation is it tells you the infinite possibilities for x and y combinations. So if x is 4, y has to be 5, and that point will be on the line. Or if I were to pick -2 for x, if I were to plug in -2 instead, that would mean y would have to be -1. So if I were to go left 2, then y would be -1. It would be like approximately there. I'm not graphing this very well, but there's the idea. So an equation represents the infinite number of points that create this line. Now, what would happen, though, if I were to put a greater than sign here?
Y has to be greater than x plus 1.
So now y is greater than x plus 1. Remember when Steve told us to plug in 4?
It can't be equal to 4.
So y, but what do we know about y?
That it's greater than 5.
It would have to be greater than 5. So we know that when x equals 4, y can't equal 5, right? So that means that this point on my graph doesn't exist now. I'm going to put a white dot there. That point doesn't exist because it can't equal 5. Okay? But it does mean that y can be greater. Where does y get bigger on a graph? 100. So y gets bigger on a graph going in the upward direction. Okay? So when x equals 4, y can't be 5, but it can be 6. It could be 7. It could be 8, and so on. It could be anything up there. Same thing here, like this point. When x is 2, y could be 3. But if y is greater than 3, then it can't be here, but it can be everything above it. And so we have an interesting thing. So now we see that, will the points on the line work anymore?
No.
No, because it can't equal. The y can't equal that value. And so to show that in this class, we use a dotted line. We just make it dotted. That means, okay, well, there's my barrier, but you can't actually be on that line. Okay? But it seems to be anything above it because y is greater than. And so we're going to be shading above it. And that means that any point up here, for any value of x, anything above that line is going to work for that equation. Okay? Now I can make a little change. What if I do this? What does that mean? If I were to put a bar underneath of this inequality. You guys know? So that means it can be equal to. What do you think that's going to do to my graph?
That means it can have the points, but it also be greater. It can always.
So now those points on the line work, which means how would I show that on my graph? Don't make it dotted anymore, make it solid. So what do you guys think would happen if I flipped this over? Instead of being greater than, I made it less than. What would that change on my graph, Lil? It would shade under it. Okay? So we've got two ideas here. No equal sign, dotted line. Equal sign, solid line. If y is greater than, we shade above. If y is less than, we shade below. And what this shows us is what points work for that inequality.
So you do shading? Like if we had homework, we would shade in
If you have an inequality, yes,
Okay.
you'll shade. So here's our summary of everything. Conclusions. Solid lines show us that points on the line work. So if you have a solid line, that means it's good. We also see that dotted lines indicate that points on the line don't work. We see that shaded areas tell us which points satisfy the inequality. So wherever it's shaded, that tells us which ones work. The unshaded areas, you notice that the part I didn't shade, that would mean those points don't work. So these are some of our conclusions that we've come to here. So here's the summary of it. And you guys didn't need to write any of that. That was all in the handout I gave you.
No, we did.
I didn't put that on there?
No, the blanks were.
Oh, I gave you some blanks?
Yeah.
Oh, I'll wait for you. I'm sorry. Go ahead. I didn't realize. Thank you for pointing that out. I owe some points to you guys who are helping me, so I'll do that while you're writing stuff. All right. You guys good? Still working on it. So solid lines means the points on the line work. Dotted lines mean the points on the line don't work for that equation. Shaded means they work. Unshaded means they don't. So that's how we show on a graph which points work and which ones don't. Solid versus dotted, shaded versus unshaded. Okay. So let's take a look at this. So this is, I don't know if there's any blanks on this one. Are there blanks on this next slide? Okay, good. All right, write this function if it in y equals mx plus b if it hasn't already been done. So if you want to graph an inequality, same thing. If it's not in y equals mx plus b form, get it that way. Graph the line, but before you connect the dots with a line, you got to ask, is it solid or dotted? Okay. If you have a greater than or less than symbol with a bar underneath, that means that it can be equal to it, and that means dots on the line work, and so you would use a solid line. So if you have a line underneath, make it a solid line. But if you have greater than or less than, that means dots on the line don't work, so you would use a dotted line. Okay? Shade the appropriate region. Okay, now how do we know what to do there? If y is greater than mx plus b, we'll shade above. And if y is less than mx plus b, we'll shade below. Now, if you guys don't know what that looks like, this is y is greater than, and this is y is less than. If you want to add that, you can. Kev, you with me? Make sure you guys are paying attention. That's what we do in school. Can't learn that way. Got your nose on the phone. All right. I don't like to call people out in class. Sorry, Kevin. It's just that I can't come and talk to each individually, so I got to put you on blast. Sorry. But anyway, now these are other circumstances we'll look at. Remember how we talked about y equals a number or x equals a number? Those are just horizontal and vertical lines. Well, everything we just talked about, that works for the horizontal lines, but the vertical ones, that's weird. How do you shade above a vertical line? That's not possible. It's infinitely high. You can't shade above it. So when you're talking about x equals a number, you shade on the left or right. Okay? So we'll see if we get to one of those. All right. So let's do one real quick. Y greater than negative 1/2 x plus 3. All right. Let's see. So, Alonzo, where do I put my first dot here if I want to graph this? At 3 on the y-axis. And then from there, Armani, which way do I go?
You go down 1 and to the right 1.
Perfect. Down 1, right 2. Now, I'm not going to connect those dots yet. So far, that's nothing new. That's what we did yesterday. We've done it a few times today. But here's where the new stuff comes in with the inequalities. Cal, I'm going to put you on the spot here. And if you don't know right away, it's okay. I'll walk you through it a little bit. But do you think I would use a solid or a dotted line here? It's dotted. Do you know why? That's right. Very good. So I didn't catch you off guard. You were on it. So since there's no equal sign underneath of that, we use a dotted line. And what that means is any point that's on this line, if you were to plug it in, it wouldn't work. You would get a false statement. All right? Good question. So think about it for a minute. I'll give you I should have given Cal a minute to think about that. So I'm going to give you guys a chance to think, and then I'm going to call on somebody. But where do you think we would shade? So think about that for a few seconds. So I'll ask Jedrick. What do you think? That's correct. You guys see how this says y is greater than mx plus b? And when y is greater, we shade above. So that means any point up here works. So you could plug any point from this area up here into this equation, and you should get a true statement. Like if you were to plug in this point here, don't write this, but 3, 5. Let's say I pick that point. If you plug it in, it'll come out saying something true, like 10 is greater than 7 or something like that. But if you picked a point down here and tried plugging it in, you get something funky, like saying like 2 is greater than 11, which doesn't make sense. So there you go. So that's how you graph an inequality. Let's do another one here. Oh, I put equals. My bad. All right. So let's do that. See if you guys can graph it. I'll give you a couple minutes. So those are your two dots, but I really want you guys to think about what kind of line and where do I shade. That's kind of the big one. So you got another minute here. If you want to check your work with a neighbor. Those are your two starting dots. I want you guys to make sure you have use where do I shade and what kind of line do I use.
The bottom.
Alright, so Vidal, what do you think? Solid or dotted line?
Solid.
I agree. Nice job. And that means that points on this line would work if you plugged it in. Next. David, where do I shade? On the bottom, because it says y is less than. So, Becca? Yes, so that means my slope is 3/1 when you're missing your run. So we would shade underneath. And that means that anything here is a solution point. Okay? So we got a little bit. There was some more I could have talked about. That's okay. This was just kind of like an extra little thing to throw in. But that's graphing inequalities. All right, guys? So we're done. Nice working with you again.